Welcome to CSEGuru. In this session, we will discuss 2D array and function example. In the previous session, we have discussed matrix addition example for 2D array and function. Now, in this session, we will discuss matrix multiplication for 2D array and function example. In matrix multiplication, we are going to use three user-defined functions. One is read matrix to read the input values for the array, and multiplication matrix, actually the logic how the matrix multiplication happens will be explained with this user-defined function only, that is multiplication matrix. And print matrix is used to print the resultant value in the output screen. So this read matrix and print matrix logic already we have discussed in matrix addition. Okay, so here we have to enter the size of the matrix. So the sizes m and n. M is the row size and n is the column size. Next, enter the elements of matrix A. So for that we have to use the user-defined function, that is read matrix. Okay, with the help of this read matrix, we need to pass the array, that is the input value for the array A, and the row size of array A and column size of array A. So next is enter the size of the matrix B. So here we need to enter the size of the matrix A, and here we need to enter the size of the matrix B, and the size of matrix B is P and Q. P is the row size and Q is the column size. Next, enter the elements of matrix B. So for that, again, to accept the matrix values for B, we have to call the user-defined function read matrix again with the elements of matrix B. Next, we need to call the multiplication matrix. Now we got the input values of matrix A as well as the input values for matrix B. Next, we need to implement the multiplication matrix. Okay. And after multiplying the resultant matrix, there is a product matrix we need to display in the output screen. So to display the product matrix, we have to use the user-defined function print matrix. Okay. So these are all the user-defined functions we have used in multiplication matrix. So here we have used nested for loops. One for loop with the I value represents the outer for loop, and the other for loop with the J value represents the inner for loop. So when I value equal to 0, for example, if you are considering this is 0, 1, if you are considering when I value equal to 0 and J value equal to 0, we have to enter some value here. Then the outer for loop I value remains same only. We need to increment the inner for loop, because until condition fails, the inner for loop will execute continuously. Okay. So the inner for loop will get incremented. J is incremented to 1. When I value is 0 and J value is 1, we can enter some value here. So this is a 2 into 2 matrix. So if you are incrementing J value further, condition will fail and the control goes to outer for loop. And I gets incremented to 1 now. When I value is 1 and J value is 0, enter some value, 1 and 0. Similarly, J gets incremented next, 1 and 1, enter some value. Okay. So likewise, we need to enter the value, and this logic clearly we have explained in matrix addition. Please refer the link for your reference. And here the read matrix and the print matrix, a simple difference. Here the for loop condition, everything is same only difference here is in read matrix we have to use scanf statement to accept the value from the user and store it with the memory locations. Okay. And in print matrix, using the printf statement, it will retrieve the value from the memory location and display in the output screen. That is the difference. Okay. So now we will check the logic of matrix multiplication. So normally, how we will do matrix multiplication in the sense, consider matrix A and its values are 2, 1, 2, 3. Similarly, the second matrix is matrix B and its values are 2, 3, 4, 1. So how we will get the resultant matrix C in the sense? Okay, so this is the resultant matrix. So the multiplication, how we have to do it here in the sense, we have to take the first row of A and first column of B. Okay, and here this is the 0th position and 1, 1, 0, 1, 0, 1. For simplicity, I have taken 2 into 2 matrix. Okay, so the first row and first column we have to take it. 0, 0 position of A should be multiplied with the 0, 0 position of B. So 2 into 2 plus 1 into 4. So we will get the 0, 0 position of C. Okay. Similarly, if you want to find 0, 1 position in the sense, we have to take the first row of A with the second column of B. And the similar process we have to implement. That is 2 into 3 plus 1 into 1. Okay. And to find the second row of C matrix, we have to consider the second row of matrix A with the first column of matrix B for 1, 0 position. Okay. So here 2 into 2 plus 3 into 4. Similarly, to find 1, 1 position, we have to take the second row of A with the second column of B. Okay, that is 2 into 3 plus 3 into 1. So if we are solving this one, we will get the answer. So 4 plus 4, that is 8. And this is 6 plus 1, 7. And this is 4 plus 12, 16. 6 plus 3, 9. So this is the resultant C matrix. So this is the procedure to find the matrix multiplication. Okay. So now the logic of matrix multiplication, how we have implemented in this program, we will check it out. So here if you are considering, we have used the variables I, j, k as well as the sum value. And if n not equal to p in the sense, that is the n in the sense, n is nothing but the column size of A matrix and the row size of P matrix should be equal. Okay, if n not equal to P in the sense, multiplication not possible, it will exist. Okay, otherwise, we have to use 3 for loops here. One is outer for loop I, then inner for loop j, then innermost for loop k. So here if you are considering the first iteration. So the logic starts from this for loop until this one. Okay. So here we will consider the first iteration of I. Matrix M is size for simplicity. We will use 2 into 2 matrix only. Okay. And the A matrix, if we are considering in the sense, the matrix A value we will consider as 2, 1, 2, 3. And the matrix B value we will consider here as 2, 3, 4, 1. Okay. And these are all the inputs. It will be passed from the main function, that is a calling function, to the called function. Okay. So user defined function will receive value from the main function. So all these values will be sent as a parameter. So now consider the first iteration of I equal to 0 and 0 less than p value is 2 and condition true. It will move to inner loop. Inner loop is j equal to 0. 0 less than q value is also 2. Condition true. Okay. Then initialize sum value is equal to 0. First initially we have to make it sum value is 0. And then k for loop, that is k equal to 0. 0 less than 2. Okay. Condition is true. Then sum is equal to sum plus a of I k. So I value is 0 and k value is also 0 into b of k j. K is also 0, j is also 0. So here what will happen? So here consider this is 0 position, 1 position and this is 0, 1. This is 0, 1, 0. Okay. So sum is we have initialized as 0 plus a of 0, 0. So a of A matrix 0, 0 position value is 2 into B of 0, 0. B of 0, 0 position value is 2. So here we will get it as 4. Okay. So the resultant matrix already we have found it, right? So that matrix value also we will write it for clarity. This is 8, 7, 16, 9. This is matrix C. Okay. So we are going to find this value first. So now it is 4. Now the inner for loop k will get incremented. Now k value is 1. Check the condition 1 less than 2. Condition true. Next up, sum is equal to sum plus sum value in previous iteration is 4. So 4 plus a of I k. I is 0 only. Now k is 1. So 0, 1 into B of Kj. K is 1 now. J is 0 only. Okay. So we will get it as 4 plus A of 0, 1 position. A of 0, 1 position value is 1 into B of 1, 0 position. B of 1, 0 position, it is 4. So we will get it as value is 8. Okay. So next iteration, K gets incremented to 2. Check the condition 2 less than 2. Condition fails. Now the kth for loop will terminate. And C of ij is equal to sum. So now C of I is 0 and j is also 0. Okay. So C of 0, 0 position, value 8 will be initialized. So here value 8 will be initialized. Okay. So now we have found the 0, 0 position of matrix C. Next, we have to find 0, 1 position of matrix C. After executing this statement, control goes to the outer for loop, that is J. Okay. Now J gets incremented. So this is the first iteration of J. Now the second iteration of J gets incremented. J is equal to 1. Check the condition 1 less than 2. Condition true. Again, sum will be initialized to 0. Next, control goes to kth for loop. Now, K is equal to 0. Check the condition 0 less than 2. Okay. And then condition is true. Then it will execute this statement, that is sum is equal to sum is 0 plus A of ik. Okay, that is A of I is 0 and K is also 0. Okay, into B of Kj. B of K is 0 and now J value is 1. Okay. So here we will get some values. We have reinitialized to 0. So 0 plus A of 0, 0 position. What is the value? A of 0, 0 is 2. Okay. So 2 into B of 0, 1. So B of 0, 1 position value is 3. 2 into 3. So we will get it as 6 here. Okay. Next, after executing this statement, control goes to the inner for loop K only. So K gets incremented to 1. Check the condition 1 less than 2. Condition true. Okay. Now find the sum value. So sum is equal to sum plus A of I K. So I value is 0 only. This is only first iteration of I, but the second iteration of J. Okay. So I is 0 only and K value now it is 1. Okay. Multiply with B of Kj. K value is 1 as well as J value is 1. So what we will get here, previous iteration sum value was 6. 6 plus A of 0, 1 position, what is the value? 1 into B of 1, 1 position, what is the value? It is 1. So we will get it as this one 1 plus 6, this is 7, we will get it. Next iteration, if we are incrementing for K is equal to 2, check the condition 2 less than 2, condition fails. This K for loop, it will exit. After exiting the kth for loop, control goes to jth for loop. J will get incremented to 2. Check the condition 2 less than 2. Condition fails and this jth for loop also will exit now. Control goes to the ith for loop. Okay. Now the first iteration of I completely over. Okay. At the end of first iteration, we will find the value of C 0, 0 position value and 0, 1 position value. Similarly, if you are implementing the same procedure in the sense, in the second iteration of I, we will find the second row of matrix C. Now we have find the first row value of matrix C. Next, if you are implementing the second iteration of I, we will find the second row value of C. The same procedure. Okay. So this is the logic of matrix multiplication. So this is the best example to implement for two-dimensional array. And here we have used along with function. So with this, we have completed the concept of arrays. That is, we have discussed one-dimensional array, how to declare and initialize, how to read and write the values for one-dimensional array, and we have discussed a few examples also along with the function. Similarly, two-dimensional array, we have discussed how to declare, how to initialize, how to read and write the values for two-dimensional array, and we have discussed the example for two-dimensional array with the functions also. Okay, so now we have completed the concepts of arrays. Next session, we will move on to the string concept. Thank you for watching this video.